All right, guys. So let's see. This is page 110, 111. Yeah, 111. Oh yeah, we okay. So we talked about this one last time. The thing, remember, in section 2:1, numbers 67 and 68. One thing to realize about these problems, they give you two things. They give you the picture, and then they give you a formula. Now, in the formula they give you 0.5 x squared, blah, blah, blah. Negative. The x is the group number. That's one thing that I think somebody didn't realize. And they give you the group numbers up above the picture. All right, like group 6 is 60 plus. So then x would be 6. So, like, the first question is about those. Yeah. That's the thing I think that threw people off the most, was what the hell does that mean? So you can estimate it from the picture, and then you can plug it in the formula. And so it was, yeah, the group. Yeah. Okay. They didn't make that very clear on the problem. So that should help you out with both of those. Cool. Yeah.
Section 2.2, page 122, question 92 and 93.
92 and 93?
Yeah.
Alright, so guys, this is 2.2 number 92. They give you this formula here for the weight, let's see, and the height. So the healthy weight versus how tall you are. 53. So they give you this formula. This would be the healthy weight, and this would be your height. So if you plug your height in here, I'm guessing in, so here's where that, so W is in pounds, and height is in inches over 5 feet. Feet. Alright, so this is why, obviously when they give you a formula, you have to know what the heck the variables mean. So sometimes they'll say like X is years since 2000. So if they say the year 2030, you're not going to put 2030 in the equation, you're going to put 30. Because it's 30 years since the year 2000. So here they tell you H is not the full height. It's the inches over 5 feet. So if you're 5'9", what are you going to put in there for H? If you're 5'9" tall, you're going to put, if you're 5'9" tall, and H represents the inches over 5 feet.
Oh, so it's 9 inches.
You're going to put 9 in there. I like it.
You're right.
I like that. Okay. Now, if you're less than 5 feet, you can maybe put some negative stuff in there, right? Let's see, blah, 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 blah.
So for 92, you would just put, for the whole thing, like, 6 over 2 minus 3 times 12 equals 55.
Where'd you get the 6 from?
The height. Oh, I think I got my.
So 92 says, and they give it to you, which is way nicer than I would be. If I'm 6 foot tall, how many inches over 5 feet am I? 12. They actually tell you that H is 12 in this problem. They are way too nice to you in this problem. If I said you're 6 feet, you're 12 feet tall. You're 6 feet tall, H is going to be 12, because that's how many inches over 5 feet you would be. Now the question says, what would be a healthy weight for a 6 foot tall person? So then you just plug in 12 for H. Solve for W. So this whole chapter is all about solving equations. And one type of equation is where I can plug a value in for one letter and solve for the other letter. So, if I was 5'7" tall, what would be my healthy weight? How would I solve for my healthy weight? If I was 5'7" tall. How would I solve for my healthy weight? What would I do? What does 5 foot 7 inches tell me that this equation means? H would be 7. Okay, good. All right, let me stop here for a second. You guys get together and say, let's not give him anything to work with. So H is height, inches over 5 feet tall. So the question would be, if you're 5 foot 7, what would a healthy weight be? So obviously I don't know what the weight is. So I'm not going to put anything here. But I know I'm 5 foot 7, so I'm 7 past 5 feet. I'm going to put H equal to 7. Plug it in. W over 2 minus 3 times 7. And I'm going to solve this equation. That's all. So if I have a relationship between two things, if I know one of them, I can solve for the other one. That's the whole idea. I like it. The important thing, though, is to understand what the variables represent. Don't just start throwing entire heights in here. You're going to get some freaky-ass answers. You could be 8,000 pounds. Oh, maybe not. Something went wrong. Yes?
I have a question on 2.4.
Oh, and 93 is the same thing, right? Just with a different function for 93, whoever asked that last question.
I asked you.
You asked, is that okay? 93, they give you the pressure of seawater at a depth d feet below the surface. So it's a little more direct, actually, right? If you ever went scuba diving, this is obviously a concern. Sorry, go ahead, George.
For 5, is it just writing down the fractions?
Number, which one?
5, 2.4.
2.4, number 5? Yeah. It says write each ratio in fraction notation. Express the fraction in simplest form. So you just got to reduce it. Cool. So that whole, a lot of those problems involve that. I like it. Yes, sir.
I have a question for section 2.2. Number 75. The thing is, like, when it came to that, I know you gotta find the least common factor.
No, you don't.
Denominator.
No, you don't. So let me build my way up to that problem. How do I solve this problem?
No, that's.
Build my way up to your problem. Yeah, you would cross multiply, right?
Yeah.
55 equals 7x, and then divide by 7. Do whatever you want to with that. Now, if I would have put an m here, would you have solved it any differently? No. If I would have put the word Jeff here, would you solve this any different? No, you'd solve for Jeff, right? It's a hard problem to solve. This one says... Yeah. So you could do the same thing, right? Exactly the same thing. I don't care that it's an x minus 2. There's something over something. I could just cross multiply.
So I don't times all of it by 2.
You could, totally.
Okay, so.
Yeah. So when you have a fraction equals a fraction, one thing is a shortcut. So sometimes actually it does too much. But you could just multiply the bottoms to the tops. Or you could multiply both sides by 10 because that would kill both bottoms. I love it. Yeah.
If you cross multiply on that bottom, it would be 10x minus 20.
Yes.
Okay.
Because 10 times x minus 2 would be 10x minus 20. Cool. So, I mean, you guys have got to... All right. I know sometimes it's difficult. You're like, what the hell does the teacher want from me? If I see mathematical reasoning, algebraic usage coming from you, I'll be happy. So you don't have to cross multiply here, right? Anthony's question is, why the hell would I cross multiply here when I could just multiply this by 2 and then kill the bottoms? You're going to get to the same place you would here, believe it or not. You're going to get the exact same answer. So the cross multiplication shortcut is related to somebody not getting an LCD, just saying the LCD would be 50, and that's not right, is it? But it's a shortcut, so that's why sometimes it oversimplifies things, when there's a much more kind of surgical way to do the problem. I love it. So if you did this on a test, how in the world could I say that's bad? That's beautiful. Cheers. But if I gave you this problem, sure. I mean, the same thing really works here, but you might as well just cross multiply. Can you make 6 become 13? So I just cross multiply. Right? It's the same exact thing that would happen if you multiply by 6 times 13.
So you cross multiply, so it's just like it's like 12x minus 5.
Oh, here.
Yeah. Oh, well, the next
It'd
one.
be 6 times 2x minus 5 equals
13 minus 7 is 6.
6 times that equals 13 times that. Cross multiply. Yeah. So equals 91. And then that one you can solve.
Then you just solve for
Solve for x like you always do. I like it. So when are you allowed to use cross multiplication? When you have one fraction equals one fraction. That's when you're allowed to do it. Did I just say you're required to do it? No. So like Anthony pointed out, you don't have to use cross multiplication when the bottoms are nice. Okay. But cross multiplication will always work. It might just make your numbers bigger than they had to be, but okay. All right. Maybe, yes.
On section 2.2, number 7, like, do those you just put not true or true, or solve them?
Well, all right. There's what's happening. If that were the case, if you end up with 7 equals 2, then you would say no solution.
Oh.
Yeah, but that's not what happens on that problem. So let's look at that problem. Something happened. Which one was it again? 70, right? This is section 2. All right. I love this problem because it's so beautifully evil. It's not even that evil. You just got to realize that 0 is a valid number. Poor little 0. Although 0 can be an asshole sometimes. We know that. But sometimes it's just trying to be a number. Take a minute and try to solve that. See what the problems might be. If you do a certain thing first, it's a little bit freakier. Just remember your process. You get all your x's on one side, you get all your numbers on the other side. Don't stop too early and freak out. Yes?
Is the answer 0?
Could be.
It's 0?
Could be. Or yeah, I don't want you doing everybody's work for them, so I don't want to let them know yet. I'm letting them find out.
What was the question?
Maybe everybody's doing it in their head. This thing here on the board. Won't be 3 anywhere. See, some of you guys.
X by itself by just minus 5y. Minus 5y to the side.
Minus 5 to both sides. Okay, okay. So subtract 5, subtract 5.
And then as you do that, do the same thing with the x.
Yeah, so you get negative x equals 4x. People freak out here, but have I gotten my x's together yet? No. So get your x's together.
So
Add x.
Add x.
Add x.
What do you get here? 0 equals And people freak out here. There are multiple places people freak. People freak out right here. But if this was 5x equals 10, what would you do? If it was 5x equals 20, what would you do? So whatever the hell this number is, you divide by 5 because you don't want a 5 there, right? This side doesn't tell me what to do. I'm the human. I tell it what to do. I don't want that 5 there, so I'm going to divide both sides by 5. So what's 0 divided by anything? 0. There you go. Catch up to Morgan. Yes, 0 is the answer. But there were multiple places where you could possibly just stop and freak out. But you don't stop until you've got the process done. What's the process? Get all your numbers on one side, get all your x's on the other side, and then divide by the number you don't want in front of your x. You're only going to get a weird answer if the x's go away. Did the x's go away here? No. So you're not going to get all real numbers or no solution as an answer. Okay. Is that cool? All right. Yeah.
For section 2.3, and then number 4.
Number 4? 4.
Yeah, it's
okay.
2.3.
When a number is decreased by 30% of itself. So how do you take 30% of something? How would you do 30% of 20?
Divide 0.3.
Exactly, because what does of mean in terms of fractions and percentages? Of means times. That's what of means. Half of 8 is 1/2 times 8 is 4. No division there. You divide, you get weird-ass 1/16. That ain't right. So this would be 0.3 times 20. Blah, blah. So I want to take a number and decrease it by 30% of itself. And then it says the result is 28. So we do this part. Thanks, Jeff. So you take a number. So what are you going to put down for them? X. And you decrease it by minus 30% of itself. 30% of times itself. X. 30% of 20 is 0.3 times 20. 30% of 800 is 0.3 times 800. 30% of a number is 0.3 times x. And think about this a different way. You can always think about this a different way. If I take 30% of a number away from itself, how much of that number is left? What percentage of the number is left? 70%. And sure enough, what's 1x minus 0.3x? 0.7x. So you can actually start here if you wanted to. If I take 30% of it away from itself, 70% of it is left. Bless you. Okay. And then, of course, you just one more step and you're done. All right. All right. Anything else from homework stuff? All right. I love you guys so much. You know you can ask me any damn thing, right? You know I'm here. You know how much I would cost if you try to get me off Craigslist. That costs a lot of money. You got me. If you're doing your homework, you're experiencing troubles, you ask questions. If you're having no trouble with the homework, that's awesome. But from what I saw in the last test, I don't think that's true. Yes?
30, you can do 33 or 39 on 2.3.
Okay. So 33. In case you guys have not done this yet, let me summarize it up here so that you can do it right now. You go into a discount warehouse, and you got two plans to choose from. Plan A is an annual membership of $100. So you have to pay a fee of $100. And you pay 80% of the manufacturer's recommended list price. Plan B you get an annual membership fee of $40. So you save some money on the fee, but where'd it go? You pay 90% of the list price. Let me make sure you guys really understand what's going on. So if I pay a higher fee to begin with, I can buy stuff from this warehouse at 80% of cost. But if I pay a lower fee to begin with, I still get a lower cost to pay, but it's not as low as this would have been, yeah.
So my question about this problem is, in the setup of the problem, would it be 100 plus 0.8 m equals 40 plus 0.9 m? The units.
All right, so let's build our way up there. I'm trying to build my way to it. In fact, not everybody here has done this problem yet, so let's try not to say a word about what's actually due yet. They're asking you, the question is, how many dollars of merchandise would you have to purchase in a year so that both plans cost the same total? So what is it that I don't know for this problem? Say again? Well, I don't know the total amount. Yeah, the list price, the total amount that I'm going to spend, right? The total merchandise I'm going to try to buy. So the unknown is the total amount purchased, the list price. That's what you don't know going in. So yeah, it sounds like, Morgan, you called it M for merchandise. I love it. So I'll do the same thing. So let's call this M for merchandise. So if you have plan A, can you take a minute and try to write down an equation that represents how much money total you would pay if you're trying to buy this much merchandise? This cost here. And I'll get you started. How much do you pay on plan A even if you never go to the warehouse at all? How much do you pay just to become a member of this plan? $100. So for plan A, it's 100 plus something. So again, what you can do is, since this is what I don't know, give yourself an amount. What if I bought $200 worth of stuff? How much money would I pay in the plan A? I'd pay $100 plus what? Because what does this say? So I pay $100 just to become a member of the plan, and then I go to the warehouse and I get stuff and I take it to the register, and it costs M normally. Let's say it costs $200 normally, but I'm special. I paid for the plan, so they're going to sell it to me for 80% of what it would normally cost. Right? So I got to pay $100 plus 80% of 200. Well, let's build it up. So like you said, 80%. How do I write that as a decimal? 0.8. 80% of means times 200. Now, where'd that 200 come from? Out of my brain, out of nowhere. Right? What could it have been? 300, 500, $2. I don't know. Right? Give me anything. So that's where I'm going to put That's the unknown. I just gave myself, I did this several times with all these word problems. I gave myself a number because our brains don't work with M, our brains work with numbers. And then we go, oh shit, that number I made up, I'll do the same thing that I did to it, I'll do the same thing to M. Because whatever number I make up, would it be any different? What if I would have said this is $1,800 worth of stuff? Would I have done anything differently? No, I would have still said 100 plus 80% of that number. So for plan A, it's going to be 100%, $100 plus 80% of M, because M represents the amount I'm going to actually try to purchase. So what's plan B going to look like? How's plan B going to be different? $40 to start with. No matter what I do, I got to pay $40 just to become a member. If I never go, well, you just donated $40 to the warehouse. Good for you. So it'll be 40 plus it's 90% of the merchandise you're going to buy. And then it just tells you when are these two plans equal. So what do you do with these expressions? You set this one equal to that one. You solve for M. So the question says, when are the plans equal to each other? Now, why the hell would I want to figure that out? Why would I want to set them equal to each other?
To figure out which one's going to save more.
Exactly. If I know where they're equal to each other, then if I buy a little bit more, one of the plans is better. If I buy a little bit less, the other plan is better. Sure, like the Costco. Exactly. I don't know. I'm not a member of Costco, but I don't know if they have different levels of membership. The different levels of membership are dependent on how much you buy, maybe? Yes? Same kind of thing then. Okay? So which level should you get depends on an estimation you make about how much you're going to actually buy there. Right? If you think you're going to buy a hell of a lot, you want to get this one, don't you? Because it's more money up front, but you're saving 20% every time you go. Where if you don't think you're going to buy that much, you do this one. Because then it's less money up front. And 90%, you're only saving 10%, but you're not going to buy that much. So what we're doing right now is we're figuring out where's the break-even point. Where's the point where they agree with each other? On one side of that, one plan's better. On the other side of that, the other plan's better. This happens so often. Holy shit, this happens so often in life. That's really good to be able to figure out which one's better. So you set them equal to each other and you solve for M. You can see exactly how much merchandise would mean that these are the same result. Neither one of them would be better than the other one. If I bought less than that, this one's better. If I bought more than that, this one's better. Okay? Is that cool, Morgan?
Oh, yeah.
Okay.
I don't have my book, but I don't know what number it is, but it's not that I wouldn't put the one about the population, the problem, I think it's only like the next one. It's like the next one.
The one about the population of Greece?
Yeah.
Maybe? Okay.
That's, yeah, I think it was. What I didn't get about it was, I know they said it's the same point, but it kind of confused me because the population is dead, so it would be equally, you know what I'm saying?
So see, this is number 36. So it says in the year 2000, the population of Greece was 10,600,000, with projections of a population decrease of 28,000 people per year. So decrease 28,000 per year. Now, one thing I can do for myself doesn't really matter. But I could cut off the 1,000 so I have smaller numbers in my equation. So I can say these are in the thousands, these numbers. But if you didn't think about that, let's pretend like you didn't think about that. In the same year, Belgium, little tiny Belgium, had 10,200,000 people. And it's growing by, it's decreasing by 12,000 per year. So why does it make sense that at some point these will meet up? At some point the populations will be equal. Why does that make sense?
Because, Greece is dying quicker.
Aw, dying. That's horrible. They might just be moving.
We already have three dying.
Oh man. Some of this is deaths, sure, but some of it is moving. Let's not say everybody's dying. But they aren't doing that great, but oh well. They ain't all dying either. So they're losing more people per year. They start at a higher number, but they're losing more per year. So it kind of makes sense that these will match up at some point. Boom. Right there. Does that by itself make sense? So you actually have to be able to reason this stuff out beyond mathematics. Just step back from the problem and say, does it make sense that this is going to happen? Yes, it does. So tell me, for Greece, how many people will there be in 2010? How would you figure that out?
10 million minus 28.
Sorry.
You just